Welcome again to day 13, another day of learning. Today we shall be looking at performing a loading update in Kubernetes. I hope you're all excited as I am to learn today. So let's go on and read what's going on here. They're saying objectives, performing a loading update. They're saying updating an application. They say rolling updates allow deployments update to take place with zero downtime by incrementally updating pods instances with new ones. So they're saying rolling updates allow deployments update to take place with zero downtime by incrementally updating pods instances with new ones. Okay, and we must be having this idea already by now, given what we've been studying the past few days. Now they're saying users expect applications to be available all the time, and developers are expected to deploy new versions of them several times a day. Okay, and they're saying in Kubernetes this is done with rolling updates. Okay, we as developers, we ensure that the application is available to our clients or customers, okay, using rolling updates. So let's see how to do this. They're saying a rolling update allows a deployment update to take place with zero downtime. It does this by incrementally replacing the current pods with new ones. The pods are scheduled on nodes with available resources, and Kubernetes waits for those new pods to start before removing the old pods. Okay, that's good. We go on. They're saying in the previous module, we scaled our application to run multiple instances. If you remember, that was using the replicas subcommand. They're saying this is a requirement for performing updates without affecting application availability. By default, the maximum number of pods that can be unavailable during the update and the maximum number of new pods that can be created is 1. The maximum number of pods that can be unavailable during the update and the maximum number of new pods that can be created is 1. They're saying both options can be configured to either numbers or percentages of pods. Okay, this is good to know. In Kubernetes, updates are versioned and any deployment update can be reverted to a previous stable version. So updates are versioned and any deployment update can be reverted to a previous version. All right, let's continue. So they're saying a rolling updates overview, and there's a diagram here. Okay, so I see that this is the deployment, okay, and there's a service which has been exposed for each deployment, okay. So this is the service, the app which has been updated with its new IP. Then I guess this one which is dim is the old one. Okay. All right. Let's move on. Saying if a deployment is exposed publicly, the service will load balance the traffic only to available pods during the update. Which means if you're using, like, for example, type load balancer, okay. So you're saying similar to application scaling, if a deployment is exposed publicly, the service will load balance the traffic only to available pods during the update. So they're just repeating what we had up. They're saying an available pod is an instance that is available to the users of the application. An available pod is an instance that is available to the users of the application. Okay. Rolling updates allow the following actions: promote an application from one environment to another via container image updates. Okay. Promote an application from one environment to another, roll back to previous versions. Okay. Continuous integration and delivery of applications with zero downtime. Okay. So if you've heard about CI/CD, yeah, this is it. Then we move on. Here they're saying in the following interactive tutorial, we'll update our application to a new version and also perform a rollback. Okay. So our application is going to be updated. We're going to promote, okay, our application. So by promoting, they mean creating a new version, okay, updating it to a new version. For example, like from version 1.0 to version 1.1. Okay, then after that, we shall move from what we have at 1.1 to the back, okay, to 1.0. So let's move on. Say update the version of the app. To list your deployments, run the get deployment subcommand. Okay, of course, we need to do this. I'll get to our terminal. Okay, I need to first of all start. Okay, minikube. I think I had stopped it. So I'll say minikube start to start our cluster. Okay, so it's starting because right here, if I try to do kubectl get deployments, okay, if the server is not working, okay, we shall not get anything. You see, it's still trying to start it. That's why you see kubectl get deployments is hanging. All right, so you can see now we can see that we're getting 2 out of 2. Why? Because kubectl is now configured, okay, to use minikube. All right, let's move on. So they're saying to list the running pods, run get pod subcommand. Okay, simply the same command, but I change the resource from deployments to pods. Okay, so we see we have two pods running. Okay, they're saying to view the current image version of the app, run the describe pods subcommand and look for the image field. Okay, so I'll clear my screen and clear and say kubectl describe pods. Okay, so they're saying look for the image field. So where's the image? Okay, so image is here. Okay, so we have the image, okay, and the image ID. Okay, you might find guys who know Linux skills doing something like kubectl grep, okay, image simply means filter and look for image. Okay, that's why sometimes having Linux skills is good. It can save you a lot of time from having to do it manually. So by doing this, I am able to see that, yeah, this is what the actual image by just this command. Grep simply means filter. Okay, think about it. Think about it as a regular expression filter. Then when they move on, they're saying to update the image of the application to version 2, use the set image subcommand followed by the deployment name and the new image version. Okay, so yes, they're saying kubectl set image deployments / Kubernetes bootcamp. Okay, so this is the deployment. Okay, so after that they mention the image. Okay, which is this. Okay. And you can see that this is now v2. Okay. They're now changing the image to v2. Okay. Because if we come here, I think this image name, okay, is v1. At the end, it has this string called v1. So this is version 1. And now they're updating it to this. Okay, so they're saying the deployment Kubernetes bootcamp is new images now. This one, okay, which is v2 version 2. Okay, so yeah, kubectl set image for this deployment, change it to this new image. Okay, so I'll copy the same command, paste it, hit enter. So you see it says image updated. Okay, these commands are actually easy to understand. I'm not seeing anything really difficult about them. Okay, we have set image. Okay, kubectl set image. Very simple. All right, we move on. They're saying the command notified the deployment to use a different image for your app and initiated a rolling update. Okay, so they're saying check the status of the new pods. View the old one terminating with the get pod subcommand. I hope we're not too late. Kubectl get pods. Wow, it's already running. Okay, both of them are already running. I think if we had done it immediately, we would have seen that one was being set and the other was being removed. Let me try. Okay, it doesn't it wouldn't like set it again because it was already there. Okay, but ideally we're supposed to see that one is being terminated and one is being created. Okay. Anyway, let's continue. So they're saying first check that the service is running. First check that the service is running, as you might have deleted it in a previous tutorial step. Run described services Kubernetes bootcamp. If it's missing, you can create it again. Okay. So you can run this command. Okay. Say I can say kubectl get services. Okay. We have it here. Okay. We have one of type load balancer. Okay. If I clear and press the same command, not this, but I have to add kubectl describe, then my service name. Okay. Kubectl, I added something extra, which is unnecessary. Okay. So it has described it. Okay. So yeah, it is running. Okay. And now this type of load balancer. So they're saying if it's missing, you can create it again with this type. Okay. But you should know that this one now they're using type of node pod. And by now you should know what node pod means. So they're saying create an environment variable called node pod that has the value of the node pod assigned. Okay. So by now we should be familiar with this. Okay. So I'll copy this to create that environment variable. I'll clear my screen, paste. Okay. And here's the pod we're interested in. Okay. So an environment variable simply helps us to store. Okay. That's why it is important sometimes to have some Linux or shell commands. Okay. To know some shell commands can help you do stuff like this in an easy way. All right. So now they're saying next do a curl to the exposed IP and port. Okay. But we know this will not work. Okay. Why? Because I'm using Docker. Okay. I'm using Docker. So we have to open what is called a tunnel. Okay. We have to open what is called a tunnel. This time they've not showed us how to do that. Okay. But I can find it. Okay. There's no need to cram certain things. It was, I think, in yesterday's when we were saying about how to scale. We have to create a tunnel. So I'll scroll quickly. to remind myself or ourselves of what to do. Okay, so this is what I'm supposed to do. Okay, so to do that, I'll cancel this. Okay, so in this terminal, I've now remembered to say, is it kubectl or minikube? It is minikube. You have to open a tunnel. I'll say minikube service. Okay, the service name, of course, is the same. This one here. Okay, Kubernetes bootcamp minus URL, like that. Okay, and this is it. This is what we need. Okay, so instead of doing this, okay, now we can use curl that. Okay, in there we are. Okay, and you see it is v2. Okay, version 2 is the one that is running. Now we can now go back to our tutorial. Yeah, that's why it's important to follow everything that we do step by step. Okay, otherwise you can easily get lost. So they're saying you can also confirm the update by running the rollout status subcommand. So they're saying I have to type kubectl rollout status, okay, then Kubernetes bootcamp. Okay, so I can clear and say kubectl rollout status, then the name of the deployment. Okay, so it has been successfully rolled out. Interesting. So they're saying to view the current version of the app, run the describes sub command. Okay, so kubectl describe pods, and they're saying in the image field of the output, verify that you are running the latest image version. Okay, so we can do that. We can say kubectl describe pods. Okay, I need to correct my spelling. Describe pods. Okay, and if we go up to check the image, where is the image? Right here. Okay, you see it is version 2, but again I've told you there's no need for us to even type that. Okay, you can use the same command but filter only the image that we're interested in. And if you look at the image, you'll see that we are working with version 2. Okay, yeah, I found this thing interesting and very easy to work with. Then after that, they're saying roll back and update. Okay, so we have now promoted our application. Okay, which is very, very easy. Okay, just to go through all this to see what we have done so far. We got the deployments, we got the pods, look out for the image field, see the current version. Okay, then we use this command. Okay, set image. So to roll an update. Okay, to promote an application to a new update, we simply use set image. Okay, that for this particular deployment, okay, set its image to this. Really easy. Really easy. Because remember, your image sort has what? Is your application bundled up with its dependencies and whatever have you, everything. Okay. So get pods, set image. Okay, that's how you promote an application. Then we verified. Okay, we made sure that actually there's a service exposed. Okay, and then yeah, we just check out the rollout status. Okay, and it was okay. Now we're now reversing. Okay, so they're saying let's perform another update. Try to deploy an image tagged with v10. Okay, so if you look at the end here, it is tagged with v10 version 10. Okay, so the same thing applies. We shall use what? Set image to do the update. Okay, so the only part I'm going to copy is this. Okay, the current deployment. So this is the current deployment you want. This is the current deployment whose image you want to update, and this is the new image. That's the difference. Okay, but the key statement is set image. Whose image whose image are you setting? This deployment. And what's that new image? This other one. Okay, so I can just copy the whole thing, come to my terminal, paste. Okay, says image updated. If I say kubectl get pods, okay, so you see we have an error saying error image pool. Okay, so it says used get deployments. Can also use get deployments. See the status. Okay, still saying it's 2 out of 2. Okay, so it's saying available 2, up to date only 1. Okay, and this is, I'm very curious about this. Okay, so let us go on. So they're saying, notice that the output doesn't list the desired number of available pods. Run the get pods subcommand to list all the pods. Okay, but luckily for me, I'd actually run it. Okay, do you see here? I ran the kubectl get pods, and I saw that there's an image. Okay, and also when I say get deployments, okay, you see that what is how many pods are available to, but what is up to date is only one. Only one pod is up to date. Okay, so it says, notice that some of the pods have a status of image pull back off. Okay, this one here. Okay, so I'll clear just to show you kubectl get pods. Okay, this is it now. Okay, image pull back off. Okay, so it got an issue. Now it is showing us the image pull back off, which matches exactly what they're talking about here. Now they say, to get more insight into the problem, run the describe pods subcommand. So let me run the command. I'll need space clear kubectl describe pods. Okay, so let us continue. The thing in the events section of the output for the affected pods, notice that the v10 image version did not exist in the repository. So where are the events? So you say events, okay? And so you see it tried to pull, okay, v10, then it says failed to pull image, okay? It failed to pull the image. Then after that it says error response from daemon manifest for this image, says not found. Okay, manifest unknown, failed to fetch v10. Okay, then we have that error, saying error image pull. Okay, meaning an error associated with something wrong happened while pulling the image. And in our case, it is because the image does not exist. Okay, then we have finally the image pull back off. Okay, so it stopped trying to pull the image. Okay, because it does not exist in the repository. So they're saying to roll back the deployment to your last working version, use the rollout undo subcommand. Okay, so this is the name of the deployment. Okay, that's not bad. Looks quite easy. I guess the more you do the commands, the more they stick in your mind. So I'll say kubectl rollout undo, then I paste the deployment I want to roll back. So it says deployment bootcamp rollback. So let me look at the get deployments command. So look at this, it's saying 2 out of 2. But last time it was saying only 1 was up to date. Yeah, so this is good. We move on. They're saying the rollout undo command reverts the deployment to the previous known state, which is version 2 of the image. So they're saying updates are versioned and you can revert to any known state of a deployment. Use the get pods subcommand to list the pods again. Okay, by now you should be familiar with these commands. Okay, so yeah, all looks okay. Okay, our two replicas are working. So they're saying to check the image deployed on the running pods, use the describe pod subcommand. Okay, so I'll do the same. Clear my screen, get pods. But this time I'm not going to show everything, but simply filter out for the text having image. Okay, so I seen this. It has rolled back to version 2. Okay, we have version 2, not the V10 that we're trying to get. Then they're saying the deployment is once again a stable version of V2. Okay, the rollback was successful. Remember to clean up your local cluster. Okay, so to clean up our local cluster, we simply they're deleting the deployment that we have, and they're also deleting the service. Okay, fair enough. Okay, so I'll simply copy that and clean up our local cluster like that. So the deployment has been deleted and the service has also been deleted. Okay, very easy to understand. So if I just simply give you a recap, how if you want to update, okay, because what we're essentially updating is the image. Okay, so to update, we use the set image. Okay, so it's a set image and mention the deployment, whose image you want to update, and the new image. Okay, as simple as that. Then after that, if you have no service on that deployment, you expose the service. Okay, after exposing the service, you can test it. Okay, or you can also check the status of the rollout. Okay, by using rollout status. So the commands we've learned today are two: set image, rollout status. Okay, then to roll back. Okay, we have the command called the roll. What is called the rollout undo. Okay, is for undoing. Okay, this one rollout undo. So set image for setting, rollout status is the status of the rollout undo for moving back to the previous known state. Okay, yeah, and then of course delete to clean up our cluster. So this has been another good learning experience. So I'm going to go ahead and stop my cluster. So this has been mini cube stop. Okay, like that. So thank you for learning with me again today. Let us meet